天飘在湖面，就像牧羊姑娘纯洁的笑脸，千年沉默守候，千年的爱恋。天歌唱着，情歌唱着，心中的思念。来到青青草原，美丽的新女湾，我听到你多情多情的呼唤。当清晨的霞光把你的热情点燃，我取了白色的骏马，飞到你身边。来到青青草原，美丽的新女湾，我听到你多情多情的呼唤。当清晨的霞光把你的热情点燃，我取了白色的骏马，飞到你身边。
How to teach inclined welding. On the screen, with the working area x-axis 3 meters, y-axis y and 1.2 meters. Right now, we locate an iron bed. The left button located at the original point 0, position with x distance 940 millimeters. The y width 908 millimeters. The button surface at z equal to 0. The top surface at z equal to 37 millimeters. And let's continue to teach how to do spot welding as well as the line welding. Let's enlarge the corner first. We weld this corner to see the joint. For the welding, all the corners with 2 spot welding, 2 spot welding. This is line welding. Line welding in these positions. The original points at this point. The button is z equal to 0. The top z equal to 37. The plate 12 millimeters thick. Totally height 37. These points, the x minus 55, the y plus 19. The z started at z equal to 10. The second spot welding from the top down 10. The top z 37 down 10. So the second welding at z equal to 27. This is what we want to do at the first corner. Okay, how to do it? Let's change to the teach more. And teach more, just add 1 last. Use k value 7. The k is Cartesian coordinates move function. We move to these points. These points s equal to minus 55. The y equal to 19. The z 10 millimeters high. Okay, the tool lower down at the position. Let's see the view from this direction. reset it. Then we have to incline the tool for welding. How to incline it? These points don't move. RY first. RY plus for 30 degrees. We change to Cartesian coordinate system. Remove the first line first by renew. Okay. RY plus 30 degrees. Press 3 times. 1, 2, 3. Right now, 120 degrees. And then let the tool to turn to this direction. Then we have to rotate RZ minus twice, once, twice. Okay, this is the inclined angle what we need. Then we have to retract back. Suppose for 20 millimeters in this direction, so we have to use S minus, press once and twice. This point is the first point. What we need in the system, we have Cartesian coordinates and join more two systems in CMS JPP. But inside internal data we save as join mode. The join mode equivalent to the position of the model. So this is internal data use. So we change to join mode and save these points in the first line. Simply press line. The KA created. The data be put inside the data area. Then we thrust in the inclined direction by change back to the Cartesian coordinate system. Use X plus, press twice, once, twice to the welded points, and change back to join mode and use line to teach the second point. And the third point just retract back as the first line's position. So we use head tail to change to the head and move to the line 1 and copy this data into the line 3 by add one last and get machine coordinates. So this data will replace the data in here and give K value 8 and the cutting speeds give 100 millimeter per second and the lift height give 20 millimeter and to create the third point. Then we see these 3 points work okay or not. Press run. You can see insert in and then retract back in the inclined direction. Okay, that's okay. Then we have to add something in front, add something in rear. We hope the tool lower vertically and inclined thrust in and retract back and put in the vertical direction and in the C axis and the Y axis in 0 positions. Okay, how to do it? Then we change the view. To see the hinge here, we change to the head and move to the first line. How to insert points in front of line 1? Right now 3 points only. the method is put the index in line 1 and use insert functions to insert one line. You can see the line 1 and line 2, the data all the same. Right now become 4 instruction line. And we turn the y-axis back to vertical and use modify the line 1. Okay, this is what we want to do. These points don't move, just turn the angle to the left. How to do? We just change to Cartesian coordinate system. Can let the tool tip don't move, and the turning around y minus to reduce 122 into 90. Y minus press 1, 112, 10 degrees less, and press second 102, and press the third times 92, and then we change to 90. How to do it? Lower to multiply 10, still by pressing y minus. Press first the button. Right now 90.5, 19.3, 19.2, 90.1, and 90.0. Okay, forget 0.079. We say these points, this is vertical direction already. Replace the first points by the machine coordinates. How to do it? Just use modify and get the machine coordinates. Okay, that's it. And the C going back the 0 positions as well. So very good. Then we have to add the first line at the real. The first line coordinates in here already. So we add 1 last. Get the machine coordinates. Give k value 8. And leave height. Give 20. And speeds 100 millimeters per second. The rear and the front just similar. We vertical lower down, incline the tool, incline in the welding positions. We have to reverse, incline the retract back, and turn the tool vertically and retract back to higher position. So 5 points already, but you can see right now the Z still 26, lower length 37, the top surface. So we have to lift the tool tip up 20 meters to change to multiply 1000, the highest as the speed first. How to lift the tool? We just use join mode, G3 plus. G3 is Z, move Z plus direction. Press once, press twice. Then you can see the Z value become 46.8 millimeters. Higher length 37. Then we have to replace the first line. How to replace? We change to the head first. Right now is in line 1, number 1. Use this point to replace the first one, but the first one have to be duplicated first. We use the insert to duplicate the first. Then we have to redo it again. Okay, how to redo? Just press G3 plus once, twice to let G3 become 46.8, and replace the first line. How to do it? Simply by press modify function and get machine coordinates. So you can see 48, 46.8, and OK. So the first line be changed. Then we have to add these points at the button. So we use add one last and get the machine coordinates and give the k value 8 and give z height 20 meter and get speeds 100 millimeter per second. OK. Then that's it. Then we see to move to the head, move to, and visually to see the movements at the screen. Vertical down and then incline in, and incline back, and retract back to the 46.8 positions in z direction. So everything seems okay. So after this, the welding at this corner at z equal to 10 positions, okay. But we have another point to weld. The other point to weld has to be 10 meter lower than the surface. So 37 minus 10 equivalent to 27. So we have to duplicate from z equal to 10 to z equal to 27. How can we do? Simply by choose set array function. The z direction 2 points, the y direction 1, the x direction 1. So the x direction distance don't care, give 0. The y give 0. But the z direction from z 10 to 27, then we have to increase the distance in z direction by 17 millimeters. Then press OK. You can see the points become 14 instructions. And we go to the head and to see if working OK. The first one, the second one, and then retract back to J4 and J5, 0, 0 positions. So this is OK. Finished the first corner. And then we survey the first corner just equivalent to this corner, just equivalent to this corner, and equivalent to this corner. So we can duplicate the first corners to spot welding to here, and to here. Right now, forget these 2 points. We duplicate to the closest corners in here. How to do it? Can we still use set array function? The answer is yes. But this time, the duplicate is not a z direction. It is the y direction. So the z distance becomes 0. So how much for the y distance? From this point to this point, how much? We go back to the engineer drawing. From this coin to this coins, so we have to use 33 at 23 at 25. So from here to here is 48. So we fill in this place by 48. Okay. Then this corner finished as well. So we move to the head to the first points and to see, visually to see these 2 corners welding. The first points, retract back the second points, the first points, the second points, and retract to the highest position. So this is good. This is the way what we do it, what we doing the inclined welding. Now we save this CC file to give a file name as test 300. Then we're doing the points in here. We have to remove the data in this area simply by press renew and press retract, then to 00 positions. Okay, let's do these points. These points we have to survey the join. These points is half of 940. So from here to here is minus 470. But to where in here, the half of 25 is 12.5. In the half positions, it must be from here 6.25. So we use 470 minus 6.25 to get 463.75. This is x coordinates. Okay, then we add one last, give k value 7, and the s coordinates type minus 463.75. So how much for y? The y is the width of the bar, 19. Okay, give 19. How much for the z? The top surface 37. 37 minus 6.25 to get 30.75. So the z is 30.75. Okay, then the tool lower down and in position, and we cancel the data by renew in here, and we have to lower the tool. This is 45 degree inclined, so we have to lower the tool 45 degree. How to do it? Change to the Cartesian coordinates. Turn y plus 45 degrees. Right now it's 90 degrees. So the totally should be 135 degrees in here. So we press once, twice, third times, 4 times, and 5 degree more. So we change to multiply 10. First press to see 130, 133, 134, 134.135 already. So the angle we get, but we still have another angle to change. Let's turn the view. We have to incline the tool to this side to avoid to touch the bar at the left sides. So how to change the angle? By turning in Cartesian coordinate system to turn around RZ minus. Let's change to the fastest speeds. RZ minus, press once and press twice. So this is the result, inclined angle, what we get. And we has to insert from outside to these points. Let's retract back along S minus direction by 20 millimeters. So we have to press S minus button for twice. Once, twice. Okay, this is points. What we get. We have to change back to join modes and press line to teach the first points in here, and then change to Cartesian coordinate system again, and press S plus once and twice to the welding point, and change back to join more and teach the second point by line function. We get it. And then the third point equivalent to the first point, we have to retract back to the original insert position. So how to do it? Simply by change to the head, the first number line number, and move to this point. We will copy the data to the machine coordinate system, and you can see the position. And use add one last, and get machine coordinates. We will copy the data into this area, and give k value 8, and the cutting speeds give 100 millimeter per second, and the lift height give 20, and okay, you can get the line number 3. Okay, let's see these 3 points working. It seems okay. Now we change to the head and move the data to the first line. We have to vertical down and inclined in. So how to become vertical? We have to let the tool turn around the y-axis, put into the vertical position. How to do it? First, insert one light. The first line and the second line the same. And then this point don't move, and turn the tool back the vertical direction. So we have to change into Cartesian coordinate system, and turning 136 back to 90 degrees by pressing RY minus. So you can see, press once 126, press twice 116, each time deduce 10 degrees, press third time, press the last time, become 90.7. Then we lower the speeds to become plus 10, and press fast to change RY data to 90 degrees. .54320. Okay, exactly 90 degrees. Then we have to replace the first line. Change Cartesian coordinate system back to join mode. Use modify and get machine coordinates. Okay, then the first line become this one. The y become 90 degrees. But the J5 still not a 0. The C-axis has to be changed back to 0. So we add the first points to the wheel. How to do it? Simply by pressing add 1 at last. Get the machine coordinates and give k value 8, and lift value give 20, and the cutting speeds give 100 millimeter per second. Okay. So the fifth point, okay. Now we have to change the C back to 0. How to do it? The same, we have to move to the head and move to, and use insert 1 point, and turn J5 back 0 in join mode. So we have to change to the highest speed plus multiply 1000. The J5 minus has to be pressed. Right now it's 27.8. Press once, become 19.8. Press twice, become 7.8. So we change lower to multiply 100. Still press J5 minus. Right now 70.5 degrees be reduced. Right now become 0.3. We still has to reduce 0.3 into 0.0. We lower to multiply 1. Press once, press twice, press third times. The GFI becomes 0.0. We call it back C back to the original. Okay, right now it's join modes. We have to replace the first line with these coordinates simply by choose modify functions and get machine coordinates and just press OK. This first point be altered to the justified position. Then we have to add 1 at last, get the machine coordinates, and the K value give 8, and lift height with 20 meters, and the speeds with 100 millimeter per second. Okay, now everything okay for these points. Then we run it to see the vertical and the trend inclined and inclined welding, and the retrace back and the return back to vertical. So everything okay. The totally is 7 instructions line. And how can we put this line, these 7 lines at the real of the test 300.cc file? Now we have the procedure to do. First, we have to put the instruction to the head and move to it. Right now, locate at the first line. We have to insert test 300 in front of line number 1. We have to put the index in line number 1, and then use insert file. By press the insert file, the system will ask us to input a file name. We know test 300. Simply by save it. Then that's it. You can see the join blue lights in here. Right now we can visually see if the tool path is okay. Okay, run. It will from current position move back to here and down first point, second point, and vertical down the first, the second, and move back and turn the angle, incline in and incline back, and turn back to the original vertical positions. So everything okay. Then we save CC file again. Use the file name test 300. Enter. Right. The spot welding with 2 corners and 1 in here. That's it. The spot welding we taught with the teaching finished. Then we teach the line welding in this area. 8 parts. We do 1 first. We do incline the welding in these points first. Okay, we save this data already, so we can use renew to remove the data in the data field, and use retrace back to the home positions and to find the points there. Point in here. The same, use add 1 last. Give the K value 7. The height, the plate thickness is 12. So the Z value is 12. So how much for the X value? 940 half is the X value. It is minus 570. How much for the Y value? From here, 19. And how much for this? We survey the engineer join 19 and has to add 66.5 to get a distance from here to here. So the total is 85.5 is plus, so 85.5 has to fit in this position. Okay, you can see the tool at the right position, and we have turned the tool with the inclined angle 22.5 with the horizontal. So we have to change back to Cartesian coordinates. Right now it's 90. We have to incline the 90 until 157.5. Okay, how to do it? Turning Rx, Y, Ry plus, change the speed to the multiply 1000, and Ry plus once, twice, third times. Okay, keep pressing. Right now 150. Then we have to change to 157.5. We lower the speeds to multiply 10. Continue Ry plus 151, 152, 153, 154, 155, 156, 157.3, 157.4, 157.5. This is the inclined angle what we need. Okay, then we cancel the data in here, use remove, and we have to insert the tool inclinedly from outside, insert in position. So we have to retract, suppose 40 millimeters, to let the tool tip higher than the edge Y position. We change the speed to multiply 1000. How to retract? Simply by press S minus 4 times, 1, 2, 3, 4, to see the X value. The center to here is 470. Right now is minus 433. The half is 12.5. It seems safe in here, even lower the tool tip vertically. So this is the first point. We change the Cartesian coordinate system into join mode, and then use light to teach the first point, and then change back to Cartesian and use S plus, press 4 times, 1, 2, 3, 4. Okay, to Z equal to 12 to the top of the surface, the plate surface, and change the coordinate back to join modes, and use light to teach the second point. The welding point is at the second point, and we check back to the third point. The third point, the value equivalent to the first point. So we change the head tail to first line and move to the positions, and the coordinate will be copied in the machine coordinate position. Then we use add one last, get the machine coordinates, and give K value 8, and give Z lift value 20, and give cutting speeds 100. Okay, the first points, the 3 points, we get it, and we run it to see it's okay. It's okay. Then we have to add something in front at the rear to let the tool vertical down and incline in. So we go back to the head and move to the first line. Then we use insert to insert one lines, the one first line and the second line the same. Okay, how to let the tool be vertical. We change the view. To see the hinge here. Then we have to change the coordinate into Cartesian coordinate, since this point don't move, and turn the tool vertical. So we use Ry minus, because right now is bigger than 90 degrees, press once, 157 become 147, twice 137. So we keep press to get 97, and then to lower the speeds to plus 10, still use Ry minus, keep faster to change the position back to 90.0, 92, 91, 90, 90.9, 90.4, 90.3, 90.2, 90.1. Okay, 90.0. This is vertical, the b-axis already. We use this coordinate to replace the first line. We change the coordinate system back to join mode by pressing modify and get machine coordinates. Okay, the first line be changed. Then we have to add this one, add a real to instruction line 5 by simply press add one last and get machine coordinate in here and give k value 8 and leave the height give 20 and cutting speeds give 100 millimeter per second. Okay, that's it. And let's see, run, inclined in and inclined back and turn back. Okay, even though this point still in Z 27, lower than 37, so we have to leave along Z plus directions. How to do it? Go back to the first line, move to the first line, and change and duplicate the first point first by press insert the first line and the second line the same, and then change to the fastest speeds. And how to lift at least 20 millimeters high, simply by press J3 plus lift Z plus direction, press once and twice. The position right now is 47, higher than 37's surface Z position, and replace the first instructions simply by choose modify functions and get coordinate 47 in, and OK, the first line changed to 47 already. And then duplicate at a real one points similar to the line first instruction line, simply by choose add one last, get machine coordinates and give k value 8 and the height Z height give 20 and the cutting speeds give 100. Okay, then we run to see lower down, inclined in, inclined out, and lift up to the right positions. So this corner is okay, and we duplicate the one at this size. The width of the plate is 37. So how to duplicate in y direction? The same. You say the rate. Right now is y direction. Duplicate 2, but the distance is 37. Okay, you can run to see the first one and lift out, and to the second one, and incline in and incline the retract back, and to go to the vertical. it's okay for spot welding, but right now we know from this point to this point must be a horizontal welding. So how to do it? So right now in the first instruction line, and the next corner to the second instructions, move to, and to next instruction 3, inclined, and to instruction 4, this is the first welding point. And then the next 3, inclined back and to here with 3 points, we have to cancel. And the next one with 3, totally we have to remove 6 points from next points. So we change to next points to remove. Next point is inclined back. Delete 6. Okay, how to delete? Just delete key is here. Press 1, 2, 3, 4, 5, 6. This moment, if this point is the welding points in here, that's it. Inclined welding. We move to. Okay, you see. Okay, so 4 is this point inclined. 5 is the point in here. The tool is inclined. Okay, it seems okay. So we see the next points. If you try back to here, move to. Okay, it seems okay. Let's see the whole tool pass. Move to the first line and around. You can see the tool vertical lower down here, inclined in the welding positions, and with the inclined pulse, and welding to these points, inclined in the correct direction, welding in one direction, and return back, and turn vertically and return back. Okay, let's see again. Okay, it seems perfectly. So we duplicate this tool pass 8 times to the whole this area. Okay, how to do it? The same. Set the array. The y direction number become 8. So how much between the y distance in space? Let's survey the join. This point duplicate to here. How much? 30 plus 63. So the gap between this to here is 100. So we put down this position 100. Then okay, you can see the whole tool pass. And at last lift to z equal to 47.312. We run to see the tool pass visually. The first point incline in vertical, you can see incline in, horizontal, move to the y and return back, and so on until the last one, lift to the highest position. That's it. So we finish this one. Then this CC file has to be put beneath the test 300s. How to do it? The same. Put the current position at the first line. Move to. And insert test 3 in front of first line. How to insert? Just by press insert file and give the file name test 300 and press enter. You can see the tool. And we use run to do the whole procedure and ending the demonstration.
鲜花烂漫，云朵带来吉祥，带来美好的祝愿。来到青青草原，美丽的仙女湾，我听到你多情多情的呼唤。当清晨的霞光把你的热情点燃，我骑着白色的骏马飞到你身边。来到青青草原，美丽的仙女湾，我听到你多情多情的呼唤。当清晨的霞光把你的热情点燃，我骑着白色的骏马飞到你身边。这里的蓝天飘在湖面，就像牧羊姑娘纯洁的笑脸，千年承诺守候，千年爱恋，天鹅唱着情歌，唱着心中的思念。来到青青草原，美丽的仙女湾，我听到你多情多情的呼唤。当清晨的霞光把你的热情点燃，我骑着白色的骏马